Okay, guys, here we go with lesson 10.1. Now, it's kind of new, and I'm going to do my very best to explain this to you guys. I suggest you get these notes out and just use them for your homework because I have it written down like as best as I can. So right here, questions 1 through 4, it says a review, and then questions 5 through 12 are like objective 1. So first they go through all the different types, which is a lot, and then they kind of combine them all, and you're supposed to pick based off the graph what the equation should look like. Or I think they give you the equation and you pick the graph, what it should look like. So linear, which means it's a straight line, is when you have something equals A. So I wrote right here, A equals a number. Okay, so let me scroll down on here. It'll let me. Hang on. Okay, so we have 4 types. Let me see actually if I could zoom out. See it a little all better. Okay, that's better. So first, if A equals R times sine theta. Remember, sine is the same thing as Y. So it would be like saying Y equals a number. That's a horizontal line. Okay, if it's cosine equals A, cosine is the same thing as X, so that's a vertical line. So those two are easy. It would just be at whatever number. So this, for example, looks about like 3.5. This would be R cosine theta equals 3.5. Something like that. Okay, AX plus BY. So you are going to have A cosine B sine equals C. Okay, that's also a linear line where your slope is M and your y-intercept is B, which you're used to as B anyway. So to find that, you would just do negative A divided by B all the time. For y-intercept, you would do C divided by B. Or, I mean, if you wanted to convert it to y equals mx plus b form, you could do that too. Either way, okay? Then sometimes you have theta equals alpha. Okay, so these are always going to be slanted, and it's just going to land at whatever the alpha is, and y'all know how to do that already. So it always has to go through the origin. So you can kind of look at them. If it's a line that's slanted, ask yourself, is it through the origin or is it not through the origin? If it's through the origin, it's probably theta equals. If it's not, then it's this AX plus BY. And if it's just a straight vertical horizontal line, you got to decide, is it sine or the cosine? So those are pretty easy down here. Scroll for y'all. This is just how it'll be set up, and I did one. It says it gives a problem. You pick, is it vertical, horizontal, or neither? So this was the problem. -3 r cosine minus 4 r sine. Since I had cosine and sine, it's neither. So then I just had to find my slope. That's negative a over b. So -3 over -4 is a positive 3/4, but this negative in the front makes it a negative 3/4. And then my y-intercept would be c over b. So 12 divided by -4 is -3. So you're picking the graph that goes through the y-intercept of -3, but has a slope of -3/4. So you know a negative slope looks like this. So those are really easy, okay? Then we go to the next type, and these are circles. This is when you have just plain r equals something. You're just going to get a regular circle. So remember, cosine goes with x. So if it's r equals cosine something, it's going to be on the x-axis. So it could either be in the positive or the negative, okay? And then sine is the same thing as y, so it would be on the y-axis, either positive or negative. And then if it's r equals just a number, there's no cosine or sine, it's through the origin, okay? And r is radius. Okay, so you're looking to make sure it has a radius of whatever it says. So for these sine and cosine, make sure your radius is equaling to, that's why it says down here, let me get my pen so y'all can see. Annotate, draw. Right here, you're dividing by 2 on right here for these two. Because the depth of it, that's actually diameter. Radius is just half of it. So let me erase that and scroll down. Okay, so I did 3 examples here. So 1 in red, 1 in blue, 1 in green, 1 in orange. Okay, so the first one is r equals 9. Well, since it's just r equals a number, it's centered at the origin and has a radius of 9, so it's going to go all the way to 9 right here. Okay, so the first thing that's the problem. The first thing we're going to ask you, is it centered? And you're filling in the blank, and it's going to say with a radius of blank. So r equals 9 is centered at the pole, that's like the origin, with a radius of 9. Okay. B is a sine function, so it's going to be centered on the y-axis. Well, that's the line. Theta is pi half, because pi half is right here. Okay, so it's centered at the line, theta equals pi halves, with a radius of, remember, you got to divide, 5 divided by 2. Okay, so because it's negative, that 5 is negative, it's going to be on the bottom half, and the diameter is actually 5. But the radius is 5 over 2. Okay, and the last one, C, is 12 in cosine, so that's on the positive x-axis, which is also the line theta equals 0 right here. And then the radius is 12 divided by 2, which is 6 right here. And then you would be picking the one that has a diameter technically of 12. So the graph goes with whatever number is there. But you'll have to do this first part too. So circles, again, pretty easy. This is just stuff we've never seen before, but it's really easy. The harder part comes when we're like down at the bottom with the petals and stuff, but you'll see when we get there. Okay, objective 3, I just named this weird circles because they all have different names. Okay, so this is the part that I always get confused on. It's not that hard, but like I forget which is which, and you will have to have this memorized for your test 4 and your final. Okay. So this is when you see an a plus b in the equation. It's going to be one of these weird circles, and it's questions 19 through 30. Okay, so I'm going to go to where we can see them all at once. Okay, so again, sine and cosine go with x versus the y-axis. So these have cosine, so they're on the x-axis. If it says plus b, it's going to be on the positive side. If it says minus b, it's going to be on the negative side. Okay, down here, these are sines. Again, plus b goes at the top, minus b goes at the bottom, sine goes with y-axis. Okay, so it's called a cardioid if a over b equals 1, and that's the absolute value of it. Okay, so basically, what you're going to do on these problems is you're going to divide a over b and take the absolute value of it, and then you know what kind of circle it is. Okay, a lemicon with an inner loop is when it's less than 1. And again, same thing goes. If it's cosine, it's going to be on the x-axis, plus b is positive side, minus b is negative side. Sine is going to be on the y-axis. It just changes the picture. Like this one has more, like it goes to a point. This one has a loop in it. This one is just like a curved dimple. Okay, and that's what it's called, a lemicon. This is a lemicon with a dimple. And that's if your a divided by b is between 1 and 2. Okay, so these, again, same way, they just have a little dimple in them. Okay, and then these are called a lemicon with no inner loop or dimple, and they're kind of just like a flathead, but I found in the homework they look just like regular circles. Okay, again, same things. Cosine is on the x's, sine is on the y. If it's plus b, it's on the positive side. If it's minus b, it's on the negative side. I just didn't write them out like the top again because I figured y'all would get it by the end. Okay, so let's scroll down. This is kind of just saying the same thing over again. It's just in words versus in picture form. And I like pictures better, so I explained it more on pictures. But this is saying the same thing. So however you like to use it. Down here is an example, and I did 4 examples all in a different color. So A goes with one problem, B is a problem, C is a problem, D is a problem. Okay, so I'm just going to talk through each of them, and like if you need to come back to this part and rewatch it, just rewatch it. Okay, so let me get my tool so you can kind of see where I am, I guess. Okay, so right here, R is 7 plus 7 sine. Well, 7 divided by 7 is 1, so it's a cardioid. Okay, it's a sine problem, so that means it's on the y-axis Y-axis is the same thing as this. This is the official term that you're going to see in your homework about the line theta equals pi halves. So you're going to pick that graph. Okay, so every single time you're going to add your A and your B to figure out the height. So you're going to pick the one that goes up because it's a plus 7 plus 7. And so that's on the positive y-axis, and 7 plus 7 is 14. So this is what your graph would look like right here. Okay, this one, B, is 3 minus 7. So 3 divided by 7 is less than 1. So it's a lemon with a loop. Okay, and it's a cosine problem, so that means it's on the x-axis, which is theta equals 0. So it's a minus sign on the x-axis, got to be on this side. That's the negative x-axis. And 3 plus 7 is 10, but it's on the negative side because of the minus, so it's negative. Not too bad. Okay, 5 over 4 is between 1 and 2, so it's a lemon with a dimple. Okay, again, sign problem, y-axis. These are positive, so it should be on the positive y-axis. 5 plus 4, 9. Okay, now these are the ones that are a little bit funny. So 5 divided by 1 is 5. 5 is bigger than 2, so there's no loop, no dimple. Okay, it's cosine problem, so it's about this thing, theta equals 0. So this is 5 and 1, so you got to actually do it in both directions. It's a minus sign, so the bigger part has to be negative, if that makes sense. So 5 plus 1 is 6, 5 minus 1 is 4. So that's where they get those numbers. Okay, so it's not too bad, especially if you just get these notes out and do it. It's just simple picking. Okay, moving on down. Objective 4. Okay, these equations are when you have an n, which is basically a number right in front of your theta. You're going to get a flower. And so these get a little bit more complicated. Okay, so just go through this with me. There's only a few of these, like 5. Okay, so again, sine goes with the y-axis, cosine goes with the x-axis. So if you look at the flowers, both of them, one of them is odd, the top up here, these are odd, down here they're even, but they're symmetrical on the correct axis. For this one, I could cut it down the x-axis because it's cosine. This one, it looks like it could be cut both, which technically it can, but it's x-axis because it's cosine. Okay, these are the y-axis because they're sine, which I know the evens ones look like they could be both, which they can because they're even, but it's just the way it lines up, so go with it. Okay, so if they are odd, they're gonna have that many petals. So like right here, this number I know is 5 because there's 5 petals for both of these, no matter if it's sine or cosine. If they're even, it's gonna have double the petals. So this one has 8. This number right here is actually a 4. So if it's even, multiply it by 2. That's the number of petals. If it's odd, it's that number of petals. Okay. So basically, this is what I said. It lines up on the y-axis, but you know that the y-axis is pi over 2 or 30 pi over 2. Okay, so here it's going to either line up with 0 or pi, depending on which one it is. Same thing down here. Okay, so let's go back and look at examples of those. Okay, oh, and I didn't say this, but the length of the petal is always the absolute value of A. A is found in front of the problem. So N is in front of the theta, A is in front of the problem. Okay, so this is the important stuff. I just rewrote it down here for you. Okay, steps for sketching the polar equations. This is it all pretty much out in words. Okay, but I'm going to explain it to you down here. On step 3, it does say determine the endpoints. And it's depending on what kind of problem you have. If it's sine, it has to satisfy these problems, which we did. in chapter 9. So we'll go over it. I'm going to do it again down here. And if it's cosine, it's got to satisfy cosine equals 1 or negative 1. So it just depends on what you're doing. And you only need n solutions. So whatever n is, you only need n solutions. Okay, so let's do it. And like this one, I couldn't do like the others and put 4 examples back to back. So this one I just did several examples. Okay, so I'll talk through all of them. If you get it after the first one, skip down until I get to the next objective. Okay, so here our first problem is R is equal. Let me get my draw tool out. R is equal to 3 sine 2 of theta. Okay, so I know we're sine and I know n is even. So my number of petals is 2 times n. 2 times 2 is 4. The length of the petal is a. Absolute value of a is 3. Okay, the n points, we have a sine problem. So they have to satisfy, and you have to keep the n right here in front of it. Sine 2 theta equals 1 and sine 2 theta equals negative. So where does sine equal 1? That happens on the y-axis, so at the top, at pi halves. I can't draw it on here, but I think y'all know what I'm talking about. Okay, so at pi halves plus 2 pi k, because that's sine's period, equals 2 theta. Remember, when there's a number in here, we got to divide. So this became a fourth, and this became pi k. Okay, so this gave me 3 pi over 4, and then if I add 4 over 4, 1 plus 4 is 5 pi over 4. Okay, so these two go with the positive 3 because it was a positive 1 right here. Okay, and then we got to do it with negative 1. Where is sine negative 1? Well, that's at the negative y-axis. Okay, so that's 3 pi over 2. Again, divide by 2, 3 pi over 4, and pi k. So I got 3 pi over 4 plus 4 is 7 pi over 4. So it gives me these 4 answers. And again, that's how many I was supposed to have, 4 petals. So these two, because when it equals negative 1, goes with negative 3 because that's the length of our petals. Okay, so part C, you're going to have to put in the endpoints, these. Okay, and then part D is you're typing them in as coordinates. And see, I said these go with the positive 3, these go with the negative 3. That's your X. So we got 3 pi over 4. The next one is negative 3, 3 pi over 4, positive 3, 5 pi over 4, negative 3, 7 pi over 4. So you're going to go from smallest to biggest angle for those. Okay, so where does it go through the pole? So because we have a sine problem, we do the same thing, but now the pole is where does it equal 0? So sine is 0 in 2 spots, at pi and at 0. So we did 2 equations. So pi plus 2 pi k divided by 2, we get pi halves and pi. So that gives me pi halves and pi. Okay, 2 pi k equals 0 plus 2 pi k divided by 2. We got 0 and pi k. So that gave me 0 and pi. Oh, over here, I'm sorry, I said that wrong. Pi halves plus pi is 3 pi halves. So that actually gave me 4 answers. Okay, and so then you just pick the graph, and I wrote above because I drew it up there. But you're looking at these angles, at pi over 4 angles, it's supposed to be petals. And at the poles, it's supposed to be zeros. So let me scroll up here so y'all can see it. Y'all know my pi over 4 angles are in the middles right here. So this is pi over 4, right? 3 pi over 4, 5 pi over 4, and 7 pi over 4. So those are my 4 angles, basically coming from part C. So I hope that kind of makes sense. You just want to make sure your graph has the correct number of petals. Sorry, I scrolled up way too much. The correct number of petals, and then it's centered at the correct pole. Okay. So I'll go ahead and let's talk through a cosine one. Okay, I did one of each. I did 2 evens, one sine, one cosine, and then I did an odd sine and an odd cosine. But if you get it, you think you can do it, want to try it out, you can skip it. But I'm going to go ahead and talk through all of these examples. But like I said, they're written down here. If you just use this for your homework, it'll help. Okay. So this problem is 7 is equal to 4 theta. So it's cosine and my n is even. So I have to do 2 times n, 8. The length of the petals is 7. Okay. So endpoints, you're setting them. Now it's cosine. When there's cosine equal 1 and negative 1. Well, cosine equals 1 at 0 and it equals negative 1 at pi. But this time we're dividing by 4. 0 divided by 4 is 0. 2 pi divided by 4 is pi halves. So this actually, in my circle, gives me a bunch of answers. Again, we're supposed to have 8 petals. Okay, so that's how many answers you want in part C. Okay, so obviously I have 0 if k was 0. If k was 1 with 0 plus pi halves, pi halves. If k was 2, 2 times pi halves is pi. And if k was 3, 3 times pi halves is 3 pi halves. So that came with that. And because it's positive 1, that's going to go with positive 7 in my coordinates. And I didn't actually write my coordinates out here. But just to save time, because I think you'll get it. All of these go with the x coordinate of 7. These will be the y coordinate. Okay. Where does it equal negative 1? Well, that happens at pi. Divided by 4, we get pi over 4. 2 pi divided by 4, again, is pi halves. So when k is 0, we get pi fourths, right? So pi fourths plus a half is the same thing as 2 fourths. So 2 fourths plus 1 fourth is 3 fourths. 3 fourths plus 2 fourths is 5 fourths. 5 fourths plus 2 fourths is 7 pi over 4. So all 4 of those go with negative 7. Okay, and where does it go through the pole when cosine equals 0? Okay, well, cosine equals 0 at pi halves and at 3 pi halves. So I have to do these 2 equations. Okay, again, divide by 4, we get pi over 8 and pi halves k. Okay, over here, divide by 4, it's 3 pi over 8 and pi halves. Okay, so these answers we start off with pi over 8, and then half of 8 is 4. So 1/8 plus 4/8 is 5/8. 5/8 plus 4/8 is 9/8. 9/8 plus 4/8 is 13/8. Same thing over here. 3 pi over 8 would you start with? 3 plus 4 is 7. 7 plus 4 is 11. 11 plus 4 is 15. Excuse me. And again, 16 would be your cutoff because that's when you reach a full circle. It's 2 pi k. Okay, so you're looking, but these guys right here, so these ones right here from part D are the important ones. Make sure at all of these points is where you have a petal. So at pi halves, at pi, at 3 pi halves, at 0, and at my fourths is where I should see petals. That's how you can pick your graph. Okay, hope that makes sense. Let's go into some that have odds, which odds are a little bit easier because you don't have to multiply by 2, so you just have less answers. And so the graphs are a little bit easier to see. Okay, so scroll it down. So R is equal to 2 sine 3 theta. That's the problem we got. Okay, so number of petals is 3. Length of petals is 2. Okay. Where are my endpoints? Well, when sine equals 1, sine equals negative 1. So again, pi halves and 3 pi halves, but we're dividing by 3. So this becomes pi 6 and 2 pi over 3. So we've got pi over 6, right? 2 pi over 3 is the same thing as 4 pi over 6, and 4 plus 1 is 5. Those two go with pi over 2. Okay, this one over here, when we divide by 3, we technically, and I didn't write it here, but you get 3 pi over 6. So it's the same thing as pi half. Okay, and then 2 pi over 3. So all we have is pi halves here, because if we add these, we're going to get something bigger than 2 pi. So, but you're only supposed to get 3. Okay, so make this happen. Okay, well, pi over 6, y'all know, is in the first quadrant. 5 pi over 6, we know, is in the second quadrant. And pi over 2 should go with -2. So that's this one. I know pi over 2 is right here, but it goes with the -2, so it makes it go down. If y'all remember that, with polar coordinates goes on the opposite. So that's why your graph is there. And then just going over it, where does it go through the pole, which means where's the dimples, is when sine equals 0. So 0 plus 2 pi k. Divide by 3, we got 0 plus 2 pi over 3. So that gives me 0 and pi over 3. It also happens at pi. So pi over 3 and 2 pi over 3 gives me pi over 3 and pi, but I only need 3 of them. So you use the 3 smallest. Hey, hope that makes sense. It's hard just talking to the computer because I don't know what y'all understand and what you don't, but the good thing about these videos is you can rewind and fast forward as you need. Okay, last one, a cosine and odd. So this one's 11 and 3. So n is 3 petals, length of 11. So they're just long. Where does cosine equal 1 and -1? At 0 and pi. Divide by 3. This one gives me 0 and 2 pi over 3. Those are going to go with positive 11. This one gives me just pi over 3 because 1 plus these is too big. It's pi k. Okay, so just these 3 are the ones I get because I just need 3 petals. Okay, and I wrote these backwards. The 11 is supposed to go first. So 11 and 0, -11 and pi thirds, positive 11 and 2 pi thirds. Where does it go through the pole when it equals 0? That happens at pi halves and 3 pi halves. Divide by 3. Get these 2 equations. So this gives me pi over 6. Pi over 6, 1 pi over 6 plus 4 pi over 6 is 5 pi over 6. And then over here, you only need the first one because it's just 3 of them. So pi over 2. And then you just pick it. We know that 0 happens here. Pi thirds is technically in the first part, and I'm going to draw this out so you can see it. Pi over 3 is technically right here, right? But it goes with a negative, so it's always supposed to be in the opposite. That's what we did on 10.1. This is 10.2. We just did on 10.1. That's why it's down there and not in quadrant 1. And then 2 pi over 3 happens in the second quadrant. So that's where my petals end up. All right, objective 5. Okay, these are when you get, and I call these infinity symbols. And this happens when I put x squared, but it's basically when r is squared and a is squared. So when you have a little squared in there, you'll know you'll have infinities. Okay, so your length of your infinity symbol is the length of a. Sine graphs are always going to have these 2 endpoints, pi over 4 and 5 pi over 4. Cosine graphs are always going to have these 2 endpoints, 0 and pi, and it literally doesn't get any more, doesn't get harder than that. Okay, so I didn't really do anything. That's what they're going to ask you, the length of a and where are the endpoints, and then pick the graph. Okay, that's questions 35 and 36, so just those 2. Okay, and then this is the end of the notes. 36, after that, it's just going to mix up the equations. So first they go in order with the objectives, and then they mix them all together. So they'll throw an equation at you and ask you, what does the graph look like? So you got to know, is it linear? Is it a circle? Is it one of those weird circles? Is it a flower? Or is it an infinity sign? And so you just go through them. And then 65 or 66 or 69 are reading assessments. And you basically just need your notes to go through that. So these notes are mine, guys. I probably spent the most time on, I mean, I did these a couple years ago, but the most time on these notes so they would be easily laid out for you. And y'all are the only class I've ever given a copy of my notes too. So use them. I hope they help. It's 69 questions, but you have until Thursday night at midnight. But if you get it done early and your quiz done early, you can start practicing for test 4, which I highly recommend. So good luck. I will see y'all next time.